start on this video, please make sure that if you're new to my channel, you hit the subscribe button and turn on the notification bell so that you don't miss out on any new videos. In today's video, we're going to talk about the binomial expansion, and this is what we call the binomial expansion of 1 plus x to the power of n, right? And of course, this binomial expansion, we just use it to expand binomial terms, two terms inside the brackets, right? So this binomial expansion of 1 plus x to the power of n, it only applies if n is a positive integer, right? So this is how we go about it. We say 1 plus nx plus n multiplied by n minus 1 over 2 factorial multiplied by x squared, then plus n minus 1, n minus 2 over 3 factorial, 3x squared plus, and so forth, n minus 1, n minus 2, n minus 3 over 4 factorial x to the power of 4, and so forth, then plus x to the power of n. So x to the power of n is basically the last term that we have, right, when we get to n, right? So this binomial expansion, we can write it, of course, in terms of combinations. Why? Because n choose, we know that n choose r, we can write it in this form, right? We know that this is the same as n factorial over, it's the same as, n factorial over n minus r factorial times r factorial, right? This is what we have, and you know that this is just the same as n choose r, right? So we're choosing r quantities from a total of n objects, right? So you can write it in terms of combination as well. So this will be 1 plus n choose 1 times x plus n choose 2 times x squared plus n choose 3. So let me come and write this here. So we're saying 1 plus x raised to the power of n. We can write it as 1 plus n choose 1 multiplied by x plus n choose 2 multiplied by x squared plus n choose 3 multiplied by x to the power of 3, then plus we have the continuation x to the power of n, right? So this is what we call the binomial expansion, and like I've explained here, n choose r, we're simply saying we want to choose r quantities from a total of n objects, right? So this is the binomial theorem, right, for a plus n. So a plus b raised to the power of n, simply say n choose 0, a to the power of n, b to the power of 0, plus n choose 1, a to the power of n minus 1, b to the power of 1, plus n choose 2, a to the power of n minus 2, b to the power of 2, and so forth. And at the end, we've got n choose n, 5 choose 5. In how many ways can we choose 5 quantities from 5 objects? There's only one way. So of course, here we get a 1. And a to the power of 0, this gives us a 1. So at the end, we just have a plus b to the power of n. And at the beginning here, in how many ways can we choose 0 from a total of n objects, right? There's only one way, right? Because we're choosing nothing. So we're saying 1, then b to the power of 0 gives us a 1. So at the start here, we just have a to the power of n. So it's a to the power of n plus n choose 1, a to the power of n minus 1, b to the power of 1, and so forth. Right, so what else do I have to mention here? We also have to know that any term, right, t sub naught r plus 1 is given by n choose r, a to the power of n minus 1, n a to the power of n minus r, b to the power of r. Right? So this for any term. This is the formula that we use when you need to calculate the coefficient for any term. Right, so this is what we use. So now let's attempt these questions, number 1 up to number 4, right? That requires us to apply the binomial expansion and of course use that. So allow me to use this one quick. Right, so number 1a says find the first 3 terms in the expansion of 1 minus x raised to the power of 10 in ascending powers of x. Ascending powers of x, it means you're going from x to the power of 0, x to the power of 1, 2, 3, up to whatever they want us to have, right? So the first 3 terms if we were to use this binomial expansion of 1 plus x, in this case we see that we've got a minus x, right? So it's more of like 1 then plus, right, 1 plus minus x, like this, then this is to the power of 10. And then we can apply the binomial expansion. So for number 1, if we do that, we know that we're saying 1 plus nx, n being 10, multiplied by x. Our x in this case is minus x, right? And then we're saying plus n, which is 10, n minus 1, 9, over 2 factorial, right? Or rather, let me just write it as, what is it again? Alright, well, since I have written this already, let's just flow with it. So 10 times 9 over 2 factorial, 2 factorial is 2. We are multiplied by x squared. X squared, that's minus x. Then we're squaring that. So now if we simplify that, we get 1 minus, because 10 times minus x, we get minus 10x. Then 90 over 2, that's 45. 45 times x squared, that's plus 45x squared. So this is the answer that we get for the first part. And as you can see, the first 3 terms, 1, 2, 3, we've got the first 3 terms here. In ascending powers, this is x to the power of 0, x to the power of 1, and x to the power of 2. So now let's move on to the second question. Second question says, find the coefficient of the term in x to the power of 3 in the expansion of 1 minus 6x raised to the power of 7. Right? But from here, what do we see? Right? If this is for an expansion of a plus b raised to the power of n, what do we know? We know that our a is 1 and then our b is minus 6x. Correct? Yes, it is. So now we see that our r is what? Our r is 3 and our n is 7. So now using this formula, if r is 3, 3 plus 1 we get a 4. So in this case, whatever the coefficient in the term of x to the power of 3, we know that that's the fourth term, right? So I think t, 3 plus 1, which is 4, is equal to, n being 7. 7, choose r, our r I said is 3. And then our a is 1, which is of x to the power of 0, multiplied by n minus r, right? Which is 7 minus 3. 7 minus 3, then b to the power of r, b is minus 6x, so minus 6x raised to the power of r, which is 3, like this. So if we simplify this, let's see what we get. 7 choose 3, 7 choose 3, 7 choose 3, 7 choose 3, we get a 35, so this is 35, so we get a 35 here. Multiplied by, here we get x to the power of 0, which is just the 1, and whatever that we get, we know it's just the 1. Then multiplied by whatever we're going to get here, minus 6 raised to the power of 3, we get a minus 260, so minus 216 x to the power of 3. Then now if you multiply times 35, we get minus 7,560 x to the power of 3. So this is the fourth term. But what do we want? What we want is the coefficient of this fourth term, right? And the coefficient is minus 7,560. So therefore, coefficient is minus 7,560. That's the coefficient of the term in x to the power of 3, correct? Yes. So now this is for number 2. Now let's move on to number 3. So we raise here. Here as well. Alright. Number 3 says, using the binomial expansion, expand each of the following expressions. So for the first one, we've got 3x plus 4y raised to the power of 4. Right. So here we're just expanding. We're not given up to which limit. So here we're going to expand up to the fourth term. Right. So up to the power of 4, right. So using the binomial expansion, this is for number 3a. Right? If we are to use this binomial theorem, what do we know from this binomial theorem? We know that of a plus b raised to the power of n. We know that our a is 3x, then our b is 4y, and our n is to the power of 4. So here we say a to the power of n, because this gives us a 1 and that gives us a 1. So a to the power of n, that's 3x to the power of 4. So 3x to the power of 4 plus n choose 1. So this is 4 choose 1. In how many ways can you choose 1 from 4 objects? So there are 4 ways to do that. And then multiply by a to the power of n minus 1. So 3x to the power of n minus 1. That's 4 minus 1 to give us a 3. Then multiply by b to the power of 1, which is just 4y. Then plus n choose 2. So from 4 we want to choose 2. 4 choose 2, we get a 6. Right, so 4 choose 2, we get a 6. And that 6 is being multiplied by 3x raised to the power of n minus 2. 4 minus 2, we get a 2. And then that is being multiplied by b to the power of 2, which is 4y to the power of 2. Right, and then we're saying plus n choose 3. So from 4 we need to choose 3. 4 choose 3, we get a 4. So there are 4 ways to do that. So I think 4 multiplied by 3x raised to the power of n minus 3, which is just 4 minus 3 to give us a 1. And then b to the power of 3, that's 4y to the power of 3. And then plus, for the fourth power, for the last term, we know that now we have 4 choose 4, which gives us a 1. A to the power of 0, that's a 1. Then b to the power of n, that's 4y to the power of 4. Right, so now let's see if we can break this down. 3x to the power of 4, we get 81x to the power of 4, and then plus 3x to the power of 3, we get 27x to the power of 3, and 27 times 16, we get our 432, so we get 432x to the power of 3y, plus 9 times 16 times 9, what do we get? 9 times 16 times 6. 9 times 16 times 6, we get 864. So here we shall get 864 x squared, y squared, and then plus 4 to the power of 3, that's 64. 64 times 12, see what we get. 64 times 12, we get 768. So here we shall get 768 x y to the power of 3, and then plus 4 to the power of 4, we get a 256. So 256 y to the power of 4. So this is the result that we get after we expand this using the binomial expansion. Now let's move on to number 2, part B. Right. So for part B, we need to expand x minus 2y raised to the power of 3. So now for this one, I'm just going to go a bit fast. So in this case, if we use the binomial theorem, whereby we are saying a plus b to the power of n, our a is x, and our b is minus 2y, then our n is 3. So we're saying a to the power of n, which is x to the power of 3 plus n choose 1. 3 choose 1, we get a 3. Multiplied by a to the power of n minus 1. That's x to the power of 3 minus 1, gives us a 2. Times b to the power of 1. And then plus n choose 2, we're saying 3 choose 2. Now how many ways can you choose 2 from 3? I think there's a 3. Yeah. So we can do that in 3 ways. Right? Then we're saying a to the power of n minus 2. 3 minus 2, you get a 1. So it's just x to the power of 1. Multiplied by minus 2 squared. And then plus, right, 3 choose 3. We know that we get a 1. So for the last term, we just say b to the power of n. So this is minus 2y to the power of 3. Right? So we get x to the power of 3. Here we get a minus 6x squared y. Then there we get what? 4 times 3, that's a plus plus 12x y squared. And then here we get a minus 8y to the power of 3. Right, so this is the result that we get for part B. And then I shall leave you to do part C. Right, and now let's move on to number 4. Now with number 4, what are we required to do? It says find the coefficient of the term in x to the power of 4 in the expansion of 3 plus 2x to the power of 8. So we say for the expansion of a plus b to the power of n, any term is given by this formula, right? So I say in this case our r is 4, our n is 8. So I simply say t to the power of 8, 4 plus 1 plus 5. So we know this is the fifth term that we want. So fifth term is equal to n, which is 8. Choose r, choose 4. And then we've got a, our a there is 3, which is of x to the power of 0, multiplied by n minus r, that's 8 minus 4. Then times b, which is 2x to the power of r, which is 4. So now let's do the math. 8 choose 4. In how many ways can we choose 4 from 8? There are 70 ways of doing that. So I'm saying 70. Multiply by 3, this is just 1. 3 to the power of 4, that's what, 81. And then multiply by 2x to the power of 4, that's 16x to the power of 4. So if we multiply that, what do we get? We see. So I'm saying 70 times 81, then times 16. We get 90,720 x to the power of 4, 90,720 x to the power of 4. So this is the fifth term. But the question requires us to find the coefficient. So the coefficient that we want is 90,720, which is the coefficient of the term in x to the power of 4. Right, so that's the answer that we get. Okay, so this was looking at the binomial expansion and how we would apply to exam typical questions. And please, if you're new to my channel, make sure you subscribe, hit the notification bell, and don't forget to leave a comment and drop a like. Thank you.